Okay, Wildcats. Today we're looking at Wednesday, January 9th, Attributes of Quadratic Functions, Part 1 on SML page 34. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. Characteristics of quadratics on page 34. So when f of x equals ax squared plus bx plus c, it opens upwards because the a value is positive. The vertex here is the minimum. The y-intercept is here. And the y-intercept is also the c value in the equation when x is 0. The axis of symmetry is a vertical line that cuts the quadratic in half at the vertex. The domain is negative infinity to positive infinity, and the range is y greater than or equal to k. Now, when f of x equals negative ax squared plus bx minus c, it opens downwards because the a is negative. The vertex is a maximum. The axis of symmetry cuts the graph in half, and the y-intercept is 0, negative c so you can see the negative c value when x is 0. The domain is negative infinity to positive infinity. The range is y is less than or equal to k. All right. Now vertex form. Y equals a parentheses x minus h squared plus k. Where the vertex is h and k, the axis of symmetry is x equals the h value. When the a value is positive, the direction is up, and the vertex is a minimum. When the a value is negative, the direction is down, and the vertex is a maximum. Standard form, y equals ax squared plus bx plus c. Where the vertex h equals negative b divided by 2a, and k equals f parentheses negative b divided by 2a. The axis of symmetry is x equals h equals negative b divided by 2a. When the a value is positive, direction is up, and the vertex is a minimum. When the a value is negative, the direction is down, and the vertex is a maximum. All right. The next page notes. All right, vertex form to standard form on page 34. Steps to transform vertex form to standard form. Step 1, find the vertex. Step 2, find a point on the parabola. Step 3, substitute the vertex and the point into the vertex formula y equals a parentheses x minus h squared plus k. Step 4, solve for a. Step 5, substitute the vertex and the a value into the vertex formula. Step 6, simplify x minus h squared by box method or by FOIL. Step 7, distribute the a value. Step 8, add the constants. All right. Now, standard form to vertex form on page 34. Steps to transform the standard form to vertex form. Step 1, factor so the coefficient of x squared is 1. Step 2, set up to complete the square. Step 3, add parentheses b divided by 2 squared. Because e divided by 2 squared is multiplied by the a value, you must subtract a times b divided by 2 squared. Step 4, factor. Step 5, simplify. All right. Now let's take a look at the examples. Now, here it says attributes of the quadratic function part 1. Attributes is also another way of saying characteristics. Okay, identify the characteristics of the parabola. All right, so the first thing we want to do is identify the vertex. So in this case, the vertex is 3, negative 4. Okay. Now, the axis of symmetry is right here. And it's x equals 3. All right, now it says opens upward or downward. Real simple. It opens upwards. The y-intercept is where it crosses the y-axis right here. So it looks like it is 0, 5. Now, the minimum, maximum, it's a minimum and it's the y value from the vertex, so it's y equals -4. Domain of a quadratic is always -infinity to +infinity. The range is bracket, the minimum value, -4 to infinity. All right, let's take a look at example 2. All right, example 2. The vertex is here, and that looks like it's 4, 9. Okay, so the vertex is 4, 9. The axis of symmetry is here. So x equals 4. Okay, it opens, in this case, downward. The y-intercept, it looks like, is at 0, -5. Now, in this case, it's a maximum, and it's the y value of the vertex, so y equals 9. Now, the domain for quadratics is real simple, -infinity to +infinity, and the range in this case is -infinity to 9 bracket. And it's from -infinity because it opens downward, so you're coming from -infinity, stopping at 9. All right, so finish up example 2. All right, example 3. For the graph, write the equation for the quadratic in vertex form. Then transform the vertex form into standard form. All right, so to find the equation, we know that we're using y equals ax minus h squared plus k. So before we do anything else, we need to find the vertex h and k and a point x and y. So let's find the vertex first. So the vertex in this case is, it looks like 3, -4. Okay, now that's your h and that's your k value. Now we pick a point, and I think they gave us one here. It looks like 5, 0. And that's your x and y. So now we substitute the x and y and the v, or h and k, into here. So the y value is 0. So 0, we don't know a. We're trying to find a. X is 5 minus the h value, which is 3, squared, and then plus k, but that's a -4, so -4. So now we need to solve for a. Okay, so we're going to add 4 to both sides. So 4 equals a. 5 minus 2 is, or 5 minus 3 is 2 squared. And then that's 0, that's gone. Now 2 squared is 4, so 4 equals 4a. Divide by 4. So 1 equals a. So the a value is 1. Now, once you have the a value, you can write your equation. So y equals 1, x minus your h value, which we already have is 3, squared minus 4. All right, now we're going to find the equation in standard form. So we're going to start with y equals 1, parentheses x minus 3 squared minus 4. So the first step is we need to square the x minus 3. So we have y equals 1x minus 3 times x minus 3 minus 4. Well, in essence, we don't need to worry about the 1 because 1 times this is just going to be self. So now we just distribute x, or 4, I should say. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And then negative 3 times negative 3 is a positive 9. Can't forget we're subtracting by 4. So now we simplify. That's 1x squared. Negative 3x and negative 3x combined to be negative 6x. And then 9 minus 4 is a positive 5. Okay, so now let's take a look at example 4. All right, transform the quadratic function from standard form to vertex form, then identify its vertex. Okay, so here we need to factor out from the first two terms, so that's y. So we can divide both by 2, which leaves 1x squared. 48 divided by 2 is plus 24. And then plus 145. Now this is probably the most difficult problem of the page. Now we factor the 2, we have our a value. But now, because remember, we're trying to get vertex form. Vertex form is y equals ax minus h squared plus k. We need to get this squared portion. To do that, we need to do what's called complete the square. Okay, so to do that, we're going to take the middle number, divide it by 2, and square it. But you can't just add something to the equation. You also have to subtract it away. So we have to subtract 2 times 24 divided by 2 squared. So that's y equals 2. Now we simplify this and simplify that. So that's 1x squared plus 24x plus 24 divided by 2 is 12. So it's 12 squared plus 145 minus 2 times 12 squared. So then that's y equals 2, 1x squared plus 24x plus 144 plus 145 minus 2 times 144. So then it's y equals 2. We can factor this. Before that, this simplifies to minus 143. Now, the factor is real simple. X times x make x squared. Now, we already know the factor of this because we created the factor here. 24 divided by 2 is 12. So it's plus 12 plus 12. And we know that works because 12 plus 12 is 24, and 12 times 12 is 144. Now, anything times itself is squared, so that's 2 times x plus 12 squared, and then minus 143. We now have this in vertex form. Now the vertex, remember this is minus h, so that's actually, h is negative 12 and k is negative 143. So your vertex is negative 12 comma negative 143. All right. So with that, start working on your assignment and have a wonderful Wildcat day.